Hey guys, welcome back. Welcome to Vedantu JEE channel. How are you all? Especially people who are targeting JEE 2021. That means next year's JEE. Or I should say, people who are moving from 11th standard to 12th standard. This is a specific exclusive series we have started for you guys, where we are going to cover entire 12th standard syllabus along with your preparation for JEE examination for next year. Okay, guys. So do tell me if you are a student who are moving from 11th standard to 12th standard in the comment section or in the chat box. Okay, guys. Well, as you know that we started off with our very first chapter of 12th standard, which we call as electrostatics. I hope you are aware about that. Yeah. So this chapter we started, and already 2 sessions have happened of theory. One MCQ session we have done. This is our third session of theory and a very important one, because here, as you can see, we are going to talk about electric field due to continuous charge objects. That means we are going to speak about objects like a rod, ring, and spherical objects as well. Okay, so stay tuned. Today's session is going to be very important because we are going to learn a method of integration, how it is applied in order to find out the value of electric field due to continuous charge objects. Okay, guys, so stay tuned with me. Okay, well, let me first tell you very important things for people, especially who are here on the channel for the first time. And let me start off with my introduction itself. My name is Suri Sir. Yes, guys, I'm your Suri Sir, and also fondly known as Mugambo, because when you will crack this examination of JEE, so Mugambo khush hoga. Okay, and you will crack this examination with studies which are happening on Vedantu JEE channel. Apart from that, guys, yes, very important is to know who are your teachers and what is the timetable that we are following here. Well, guys, this is your Harsh Sir. He is an amazing chemistry teacher. He'll be your chemistry guru. This is Arvind Sir, an amazing mathematics teacher. He'll be teaching you mathematics. And this poor fellow is your physics teacher. Okay, this is me, as I said, Suri Sir. And this is us on Wednesday at 9 p.m. So, guys, important to know is your schedule, that every Monday and Thursday you will have theory class for chemistry. Every Wednesday and Saturday you will have theory class for physics, and every Tuesday and Friday you will have your theory class for mathematics. That means important to remember is that 9 p.m. is a theory time every day, Monday to Saturday. Okay, and apart from that, on Monday, Wednesday and Thursday, 8 p.m. is the time for MCQ discussion. Okay, so remember, बहुत easy time slots हैं, याद रखना है, 8 p.m. and 9 p.m. channel पे आना है और देखना है कि what exactly is happening if you are in any case of doubt. Okay, easy to remember, 8 p.m. and 9 p.m. Cool, awesome. Well, apart from that, as you are aware that during lockdown you cannot go to your classes, you cannot go to your school, but guys, you can continue your studies for JEE preparation for 2021 on Vedantu's platform. You know that on Play Store, if you go and download the app, the entire study material, all the video lectures and the tests are free of cost available for each and every student. But specifically, if you are a student who's targeting for JEE 2021, guys, the enrollment is also free for the batches which we teach on the Vedantu's platform. So what is the benefit of coming to the Vedantu's platform, guys? Let me tell you, the benefit of coming on Vedantu's platform is that on Vedantu you will be able to get your doubts cleared very, very, very frequently and much more conveniently than you get your doubts solved on YouTube. You know that on YouTube we are not able to take all the doubts which are happening on the chat box. And specifically, if you are watching a session, say offline, that means not offline, rather after the live session is done, then your doubts you are not able to ask and they don't get answered very, very, very frequently. Reason being, we teachers are not just teaching on YouTube, we are also teaching on Vedantu's platform. So if you want to meet me, if you want to meet Arvind Sir, if you want to meet Harsh Sir, if you want to meet Pahul Sir, anybody, we all are available on Vedantu's platform. And right now the amazing thing is that the enrollment is also free of cost for the batch of 2021. So do come, take the advantage, meet us and get your doubts solved. Let's study on Vedantu's platform. Okay, guys? Cool. And for people who are here on the channel for the first time, yes, I want you people to subscribe to the channel as well, and also press that bell icon, because when you press the bell icon, guys, you will be notified for all the sessions which are happening on the channel. You will not miss out on anything. Cool? Awesome. So these are the important information I wanted to share with all people who are on the channel for the first time. Let's go and speak about the session plan for the day. You remember previously we talked about the electric field. We came to the understanding that electric field is defined as force per unit charge, and for a point charge we found the electric field as K Q by R square, or rather let me write it as capital. So this is basically the expression of electric field which we found for a point charge. I hope you guys remember this. Okay. But what if we speak about continuous charge distribution? That means what? Let's say we are speaking about a three-dimensional object. Yeah. So if there is a three-dimensional object like this, or any solid object like this, not just three-dimensional, any dimension object, but anything which is bigger than a point charge, then how we are going to find out the electric field because of that charge distribution. Okay. Apart from that, we'll speak about the charge elements, how we divide the body into small part, and we are going to learn how integration is going to be used to find out the electric fields due to objects like rod, ring, and spherical object. Okay, cool. So guys, let's start, and let's first understand how we basically visualize the continuous charge distribution. So if say there is a continuous charge object here, and I'm assuming it to be made up of infinite amount of charge which is given on its surface. So I've given a lot of charge on its surface. The problem is that unlike the discrete charge distribution which we discussed in the previous session, I'm not able to distinguish where one charge starts and where it ends and where does the other one start. So the problem is there is no boundary between the charges. So I will not be able to apply the principle of superposition as we were applying in the case of discrete charges which were say placed on the corners of a triangle, on the corners of a square or hexagon, anywhere. So you will not be able to apply that directly over here. So then in that case, what am I supposed to do? That is what basically is the part that we need to understand. So if say this is your object and you are interested in finding the electric field say at a point P, then what we do, we divide the entire body into small charge elements, especially the point charges. Okay, so if say the first element of charge that you see here is dq1, then we first focus only on dq1, we forget about the entire body. So because of dq1, which is at a distance r1, the electric field vector that you see here is in this direction and has a magnitude of dE1. Okay, similarly, if I talk about another charge like this, the electric field because of this, which is at a distance r2, you can see is a different vector. Similarly, another element, its separation, its electric field. So you can see that I'm basically converting a continuous charge element or a continuous charge object into discrete charges. This is a visualization that we need to understand, and when we start doing this, we basically try to convert the entire body into infinite or n number of such elements, because of which we can say that the electric fields are going to be dE1, dE2, dE3, dE4, dE5, like that. So integration is basically a process will be adding the electric fields vectorially due to all the charge elements. Yes or no, guys? So because these are all vectors, that's why we'll be integrating, and we'll be integrating the electric field due to all the charges, and we'll be able to find out the electric field because of this entire continuous charge object or a body at this point. Okay. The good part is that we'll be dealing with regular shape objects. Okay, we'll not be dealing with irregular shape objects like stones which are given some charges. We'll be dealing with objects which will be regular shapes like a linear object. First case is we are talking about a linear object. Say what you see here, guys. Yeah, so say that the pen that I'm holding is a linear object and I have given it a lot of charge, and say what you see here, before I say anything, I'm interested basically in finding the electric field at point P, but you see that there is a lambda written here. Now what basically lambda represents here is not wavelength, rather lambda is your linear charge density. Lambda is called linear charge density, which means what? Charge per unit length. So whatever is the total charge on the rod, say if I say that the total charge on the rod is Q, capital Q, and its length is L, then that will remain constant is what we assume. And what we are going to do, we are going to divide the entire continuous charge object into small charge element, and say each and every charge element has a charge dq and has a length dl, something like this. So if I take this dl here, then the dq value is nothing but lambda dl. And because of this charge, we'll try to find out the electric field dE, and the net electric field is going to be the integral of this dE electric field. Okay, getting it? What if you're dealing with an aerial charge, or you can say a two-dimensional object? This time also we are interested in finding the electric field at point P, but now what you define is sigma, and sigma is defined as surface charge density. Okay guys, I hope you guys are following here. Yep. Okay. So when we say we are talking about surface charge density, the surface charge density is basically the total charge divided by the total area. Okay, so if you are not able to see on the previous slide, no problem, I'll take you once there. Okay, so guys, this is what I wrote. I thought that you will not be able to see this. This is what I did there. dq came out to be lambda dl. Yeah, and electric field which we are trying to find out is the integral of dE. Okay, don't worry, you will be able to understand it over here. I told you that the object is a two-dimensional object. At point P, we are interested in finding the electric field, and what we have defined is the surface charge density, which is Q total charge divided by the area. And if I assume the entire body to be divided into small charge element, each having charge dq and having an area dA, then each and every element will have a charge dq, which is equal to, as you can see, as sigma times dA. Okay, and because of this element at a distance r which is placed, the electric field is dE, and you will be interested in finding the net electric field as the integral of this electric field dE. Okay, one more time, now we'll speak about the three-dimensional object. Okay guys, so if we speak about a three-dimensional object now, so guys, what you see here on the screen is a sphere. It could be a cube, it could be a cuboid, it could be a cylinder or a cone as well. So this time what is defined or written here is sigma. So what is sigma guys? Sigma is your total charge density, or normally you will just call it charge density or volume charge density also. So normally the charge density will be defined as the total charge divided by the total volume. So if you are interested in finding the electric field at this point P, you will divide your body into small charge element dq and having a volume dv. So each and every charge element will have a charge dq, which is equal to rho dv, as you can see. And because of this element, you will try to find out the value of its electric field dE, and the net electric field will be integral of dE. How do we integrate? Don't worry, I'll give you explanation on the basis of certain objects today only. Okay, and that is what I'm here for, to help you out. Use the method of calculus to find out the electric field due to various elements and various different charge objects. Okay guys, so let's go forward and speak about the electric field due to an infinitely long charged object here. Okay, so what you see here is basically say a rod or a thread which is infinitely long. Say this side is plus infinity, this side goes till minus infinity. That means a very long charged object having given a positive charge q. Okay, charge value is not given, but what should be given and what would actually be given is the charge density lambda, because it's a linear object. And what you see here, this small object is a point charge, and the charge value is going to be assumed to be dq having a small size dx. So you know that lambda is going to be charge per unit length. So you can say that dq is going to be lambda dx. I explained it to you very recently. And now guys, because of this element at point P, which is basically the point where we are interested in finding the electric field, which is at a perpendicular distance y from the rod, and say this point is your point of symmetry, let's call it O. So at a variable distance x, we have chosen this element dq. Because of this dq, say the electric field is dE, which has two components. If this is my coordinate system, this is x, this is y, then the y component is dEy and the x component is dEx. Now guys, if I consider point O to be the point of symmetry, if this point is my point of symmetry, then exactly at the same distance x on the left hand side also, there will be an element having charge dq having the same size dx and is symmetrically placed such that its electric field vector also has the same magnitude dE. Yeah, because this has the same value of x here. Okay, that means what guys? This is also subtending the same angle theta. This is also theta. So it will also have the same vertical component, that is dEy, but will have its x component as dEx, which is opposite to the other element's x component. Yes or no guys? So right now what you see on the screen, that this dEx and this dEx are the two vectors which have same magnitude and have the opposite direction. So if they are the vectors of equal magnitude, opposite direction, I'm just cancelling them out. And what is important to notice is that the effective electric field is going to be the integral of such dEy element. That means because of this rod, what we are doing without even doing any mathematics, what we are rather coming to a conclusion is that the net electric field is going to be along y direction. Means what? The net electric field E is integral of dEy. And what is dEy? It is nothing but dE cos theta. How do we come to that? Say if this is your electric field E and this angle is theta, then this component is dE cos theta. This one is dE sin theta, but that got cancelled. So that's why we are interested in dE cos theta. So guys, let's try to write down dE, this vector, which is going to be written, rather this one or this one, anything you can say. This is written for this charge element which is at a distance r. And what is r? R is y square plus x square in under root. Okay guys, so let's write that. So because of a point charge, you remember the electric field. Because of a point charge, the electric field is written as kq by r square. So that's what is going to be applied here, because what you see here is a small point charge only. Okay guys, so let's do that. So k dq by r square into cos theta. That's basically your electric field and will be integrated. We'll come to the limits of integration in some time, don't worry. So k is written, dq I'm writing from here as lambda dx, lambda is a constant, remember that. And r square will be written as y square plus x square. On the other hand, from the same right angle triangle, this is the right angle triangle, I can write the value of cos theta as y divided by r, or you can say y divided by y square plus x square in under root or power half. Which means what? Effectively, the net electric field is going to be k lambda y dx divided by y square plus x square power 3 by 2. Why power 3 by 2? Because this is power 1 and this is power half, so overall power is 3 by 2. Okay guys, so let's continue on the next sheet, and from there we'll keep on coming back to see the diagram also. Okay, so what we have written there, that electric field is integral of k lambda y dx divided by y square plus x square power 3 by 2. So if you have learned the method of integration or other problem solving of integration has been done in your class in mathematics, then guys you'll be able to integrate this very simply. To integrate this guys, the process is, in this triangle, if we are speaking about y and x, then from the triangle you can write down tan theta as x by y, or I can say that x is equal to y times tan theta. So I want to basically write everything in terms of theta now. Theta is a variable. Why it is a variable? Because as this charge element will move from plus infinity to minus infinity, x will change, and when x will change, the theta will change. Y will not change. Okay, so now in the expression I'll be able to replace x as y tan theta, but I'll need to replace dx as well. So what dx is going to be? Dx is going to be y times tan theta's differentiation is sec square theta d theta. So let's put this in the expression of electric field, guys, and what I'm getting is k lambda y into y times sec square theta d theta divided by y square plus y square tan theta, tan square theta. That means y square plus y square tan square theta power 3 by 2. Okay, so I've replaced this x by y tan theta, and that dx was replaced by this dx. So guys, from here y square I'll take out, so y square power 3 by 2 is there. So integral of k lambda y square sec square theta d theta integral of y cube comes out, and we will be left with 1 plus tan square theta, which is sec square theta. So you are left with sec square theta power 3 by 2. This cancels, so you are left with sec cube theta. So this sec square theta and this cube also get cancelled. This y square and this y cube has y square got cancelled. Effectively, what you are left with is integral of k lambda d theta divided by y sec theta. So you know that k, lambda and y are constants. They are not changing. Y is a constant, remember that. And sec theta goes up. What you'll be seeing is cos theta d theta. And guys, let me take you back here. So what you see here, x is changing. So if x becomes infinity here, if x becomes infinity, then what you have, the angle of theta will tend to, basically if x tends to infinity, then tan theta has to become infinity. If tan theta has to become infinity, then theta has to become pi by 2. So this is the limit, upper limit here. And if x goes to minus infinity, then this will become tan theta equal to minus infinity here, because x becomes minus infinity. So theta has to become minus pi by 2. Okay guys, I hope you are getting it. If you put, instead of x, if you put as infinity, tan theta becomes infinity. Okay, if tan theta becomes infinity, then theta has to be plus pi by 2, and similarly here minus pi by 2. So the limits of integration are minus pi by 2 to plus pi by 2. Okay guys, so k lambda by y, cos theta's integration is sin theta. You will be able to put the limits, minus pi by 2 plus pi by 2. When you will put the limits, it will be sin pi by 2 plus sin pi by 2, which is 1 plus 1. So effectively the electric field comes out to be 2k lambda by y. And this, my dear friends, is the result of electric field's expression because of a straight conducting wire, or you can say not even a conducting wire, it's basically a infinitely long charged wire or a rod or a thread. Because of that, at a distance y from it, the electric field comes out to be 2k lambda by y, where lambda is the charge density of the charge which is present on your continuous charge rod. Okay guys, I hope you were able to understand this. Okay guys, I know the derivation is lengthy, but something which is important from board's perspective, board's examination perspective. For JEE perspective, method is something that you should keep in mind, but I don't expect you people to memorize the method. Try to understand it. Sometimes in problem solving also it may come handy. Okay, and remember the result if you can. Okay, okay. Now next one is where we'll try to find out the electric field due to a ring. Okay, so guys, what you see here, this time also you have a ring, means the same rod which you had, a finite rod, you bent it to make a ring of radius r, and this has a charge over it such that if I try to define its linear charge density, yes, rod For rod, you define linear charge density only. So the linear charge density lambda will be dq by say dl, whatever that length dl is. Okay, but the charge is dq for sure on a single element here. So guys, let's say we are interested in finding the electric field at point P. The electric field at the center of the rod is basically your homework question for today. You have to tell me in the comment section what will be the value of electric field on the center of the ring when the uniform distribution of charge is there. Okay, I hope you can get the question. Question is, for your homework, you have to tell me what will be the electric field at the center of the ring due to the uniform charge distribution on the ring. Okay guys, so right now we are interested in finding the electric field at point P, which is at a distance r from each and every point of the ring, right? You can see that if I keep on joining such points, all the points if I'll join like that, you will basically form a cone. Okay, so from the center you have this point P at a distance z, radius of the ring is capital R, and this is your small r. Okay, and because of this element dq at point P, say the electric field is dE. Because of a diametrically opposite point, which is due to the symmetry, if I consider another element having the same electric field, and say this angle is theta, so you can see that this angle and this angle, everything is theta because of the symmetry. So you can see that again, if I try to resolve the electric field vectors here, this is going to be dE sine theta, and this is also going to be dE sine theta, and these two dE sine thetas will cancel each other. What you'll be left with is dE cos theta. Okay, first confusion that I have seen many times with student, you say that you might think that why sir did not write 2 dE cos theta. Sir ने वहाँ पे 2 dE cos theta क्यों नहीं लिखा? Because there are not only two elements which are present on the ring. There are infinite such elements. So I'm going to basically add all the dE cos theta. So not just 2 dE cos theta, I'll add n dE cos thetas over there. So we'll say that the net electric field is going to be integral of such all dE cos thetas, not 2 dE cos theta. Remember that. Okay guys. So let's try to write down the value of dE. Okay. So when we are going to try to write down the value of dE, dE will be written because of this charge element, say. Okay. Because of this charge element, I'm going to write the value of dE, that is k dq by r square. Okay. So this is k dq by r square, and cos theta also we can write down from here itself. Cos theta will be written as adjacent upon hypotenuse, so that is z by r. So this is z by r. Okay, that means k z dq by r cube. Because this point P is fixed, this point is not moved again and again. Because of that only, theta is fixed, z is fixed, r is fixed, capital R is fixed. What is changing is just the size of the element. That means what guys, when you will be integrating, you will take k z by r cube outside, and you will be left with only dq inside, and integral of dq will go from 0 to say capital Q, where capital Q is the total charge of the ring. Okay, this is the total charge of the ring. Okay guys, let's go and go to the next page and try to complete this derivation. So E is going to be k z by r cube, and the dq's integration is q going from 0 to q. Also guys, let's go back here. What you see here, r is nothing but z square plus r square in under root. Okay, so I'm going to replace that as well. So k z by z square plus r square in under root, or this power becomes 3 by 2, and this becomes q minus 0. So final result comes out to be k q z by z square plus r square power 3 by 2. That's the electric field on the axis of the ring. Okay, this is basically electric field on an axial point. Okay, cool guys, you can see that much easier integration that we have done here. Okay everyone, I hope you were able to understand this, people. Okay, Do remember the homework question that I want you people to tell me in the comment section. At the center of the ring, what will be the electric field magnitude? Okay, awesome. Now guys, coming to electric field of spherical shell. When I say spherical shell, basically charge is residing only on the outer surface here. Okay, and we are going to speak about three cases. One case will be, say we are interested in talking about electric field at a point P, and three cases that will try to find out the electric field is when this point P is outside the sphere, second is when it is at the surface of the sphere, and third is when it is inside the sphere. Will not be doing the derivation here right now. Okay, will not be doing the derivation here. Rather, I'll tell you the derivations of spherical objects later on in the chapter when we'll study something called as Gauss's law. Okay, so I'm assuming that the total charge is capital Q and the radius of this spherical shell is capital R. Okay, so guys, say the first point that we are interested in finding is when R is greater than capital R. So when R is greater than capital R, we assume that this entire arrangement is symmetric, so the entire charge is placed at the center of the sphere and like a point charge. So at a distance small r from a point charge, you write the electric field as kq by r square. Okay, means what? Just like a point charge, we assume that the entire charge is placed at the center of the sphere, and because of a point charge, the electric field is kq by r square. Okay, now next point, if r is equal to capital R, so this is again simple, the small r will become capital R, so the electric field will become kq by r square. And if I speak about the third case, which is r less than r, okay, the point has now come inside the spherical body where actually no charge exists. So here the electric field value is 0. Please remember this particular value, guys. These are very important results. More than any derivation which we'll be doing, these results are very important for us to remember. Okay, this is how the electric field is varying with the distance r. If I consider this point as r, then till the surface from O, there is no electric field. At this point, the electric field becomes maximum, that is kq by r square, and after that, the electric field starts decreasing. Okay, let me choose a different color to show this to you. This is the value 0 till r, and from here it starts decreasing as 1 by r square. So this is how the electric field is. This value is kq by r square. So that's how the graph will look like to all of us. Okay, now we'll move on to the next derivation, which is not exactly a derivation, rather the results here. So we'll be now speaking about the electric field due to a solid sphere. Okay, that means what? Now the charge is present at all the points inside also for the spherical body. Okay guys, so here what we are assuming that the charge density is uniform. Okay, that means the total charge capital Q which is given divided by 4 by 3 pi r cube is basically a constant. This is basically a constant. Okay, so again we are interested in finding the electric field at point P, which is at a distance r, which is variable. The total charge is Q. The radius of the spherical body is capital R. Okay guys, so again the similar cases we are going to discuss. The first case is when r is greater than capital R. This result will remain same. The result is going to be electric field as kq by small r square, assuming that the entire charge is placed at the center of the sphere like a point charge. Next is r equal to capital R. This is also same, which is kq by capital R square now. Okay, I hope I've written the same things here. Yep. Okay, and now the interesting case is the different cases r less than r. Now your electric field value is not going to be 0. Instead, what we are going to assume here to derive this, I'm going to consider that say you are here at this point. Now the point P is here and this is your distance r. So making small r as the radius, I'm cutting out a spherical body. You see that? And this spherical body, for this, now this point, new point P dash, is where I'm interested in finding the electric field. Okay, you're getting this? Now I have imaginarily cut down a spherical body whose value of radius is small r, because this is where the electric field is to be found. Okay, and point P dash lies on the surface of this imaginary sphere. That means what, guys? The spherical body that I'm assuming of small r radius will have, say, some charge small q. This will have some charge small q, and its volume is 4 by 3 pi small r cube. And this is equal to the density of the entire sphere, which is capital Q upon 4 by 3 pi capital R cube. So from here, 4 by 3 pi gets cancelled, and the small q charge comes out to be q r cube by capital R cube. Okay. So now, considering this very small sphere whose charge is small q, has a radius r, point P dash is at the surface, and that is where we are interested in finding the electric field. So I'll say that electric field at that point P dash, is k small q by the radius square, that is r square. Okay. Now what? Let's put the value of small q. So small q is capital Q r cube by capital R cube. This is what I have done. I have replaced this thing. So this r square cancels r square from here, and the final result for electric field for an internal point comes out interestingly very similar to what we studied in the case of gravitation also, guys. Very similar result we studied for a point inside the earth or a spherical body. Came out to be k q r by r cube. Okay. Here you see it is inversely proportional to r square. This is a constant value, and here it is directly proportional to small r. So if I try to plot this result on a graph, this is r, this is your electric field. Say this point is kq by r square. Say if I try to write down the, or rather try to draw the graph from the center till the surface, the electric field varies linearly. So E proportional to r, and from there the electric field varies, sorry, this was directly proportional to r, and then it goes inversely proportional to r square. Okay, guys, I hope you are understanding this part. This is how the electric field variation will be happening for for a solid charge distribution, solid non-conducting charge distribution. Okay, guys, I hope you guys understood the derivations that we have done. Don't worry, for a spherical body, be it hollow or be it solid, we'll do the derivations once again in a chapter, in a part of the chapter, in this part where we'll be studying something called as Gauss's law. Okay. So guys, this brings us to the end of the session. You know that there are a lot of assignments that we give away. There are study materials which have been given away, and daily updates are also being shared on our Telegram group. So I invite you all to join the Telegram group to get the latest assignments, notes, and daily updates related to the JEE channel. Okay. So if you are interested in joining, then just follow this link which is available in the description of the video. Okay. So you will find every detail in the description of the video. Come there. Okay. And do tell me the answer for the homework question. Assignment is also being attached in the description. Solve that. I'll give you the solutions on the Telegram group only. Okay. So guys, if you enjoyed studying with me today, if you enjoyed this video, hit that like button over there, and tell your friends as well if your friends are not on the channel and on the Telegram group yet. And more importantly, subscribe to the channel so that you are not missing out on anything which is happening on this channel. Okay, guys. So I'll see you again with more topics which are related to electrostatics. We'll continue in this. We'll talk about electrostatics, electric field, energy, and electric potential as well in the coming videos. We'll solve a lot of MCQs in this series. Let's make it awesome, and let's crack JEE examination. More importantly, keep enjoying physics that you are studying at home at Vedantu's platform as well. And much more important than that is that in this difficult time, you have to stay safe and be inside your houses. Stay home, Stay safe and take care. Bye bye, guys. See you all. Love you all. Bye bye.